Okay, we're going to give this lesson a go. This way you have some things to look at later. I'll probably break this up into a couple of different videos so that you can pick it up and drop it off wherever you need to. We're starting in 10.1. Okay, 10.1. This is circles and circumferences. And we're beginning with our study of circles with, first off, some vocabulary. Okay, some that you're familiar with. This is a radius. Okay, a radius is a line segment, any line segment, in a circle that has its endpoints on the origin of the circle and somewhere on the circle. So let's back that up a little bit. I really should talk about the origin first, the center or origin. Okay, so this is the center, sometimes called the origin. Okay, and we know that every point on the circle is equidistant from that origin center of the circle. And that distance is the radius. So the radius, again, is any line segment that has its endpoints on the center of the circle and on the circle itself. Okay, so this is a radius. It's just a line segment, so like if this were C and this were D, this is line segment CD is radius. Radius of circle O. This is how we write circles. We draw a little circle with a dot in the middle. Say it's a circle, circle C. And the origin is what you label it as. Okay, so here I have another very special segment. Actually, let's go to this one first. Let's label these A and F. This is something called a chord. A chord is any line segment with its endpoints on the circle. So notice the endpoint of this line segment is A and F. They are both on the circle. So any line segment that intersects the circle at both at 2 points is called a chord. Now there's a very special chord, and that's this one, EB. Notice it is a chord because it has its endpoints on the circle, but it also goes through the center or the origin. And a chord that passes through the center or origin is called a diameter. Now you probably know this already, but a diameter is equal to twice the radius. Okay? So if we were to extend this all the way to the other side in a straight line, we would have a diameter, which would be twice this distance. Okay? So that's the basics of a circle. Okay? Next, we want to talk about a special relationship between the distance around a circle. So that we use a capital C. It's for circumference. And you should have learned this already, but just in case you haven't, circumference, if I were a little ant, let's make a little ant with 6 legs. And if I were to walk all the way around the circle, the circumference is the distance that I would be traveling. And circumference is really interesting because it is the relationship, the relationship between the circumference and the diameter is equal to that special number called pi. 3.1415926 and so on. Okay, so that's that ratio. We normally write it as being able to find the circumference is equal to pi times d. But, of course, we don't typically talk in terms of diameter. We talk in terms of radius. And remember that d is equal to 2r, so circumference is 2 pi r. And we've been dealing with this all along. Again, we're going back to chapter 10. So these are concepts that you would have learned in 10 in order to be doing the area of circles and things like that. But we just tapped on it and said, you know what the circumference is. You know the distance around a circle. This is something that you've learned before. Okay. So moving along, let's use some of the things that we know to be true about these special segments and all and solve a problem. Okay. So I have 3 circles here, circle A, circle B, and circle C. Again, those are those those origins or centers, and then I have the points where they intersect. I've labeled them X and Y. And we're given some information. The diameter of A is 10 units, inches, centimeters, whatever. The diameter of B is 20, and the diameter of C is 14. What that means is this distance here is 10, this distance here is 20, and this distance here, if I made it go all the way across, is 14. Okay. We're trying to find what is XB and what is BY. So these two segments right here. Okay. So we can tell that XB is part of this radius. So I can say that BX plus AX is equal to AB. Right? So AX plus BX is AB. That's that, you probably learned it as the segment addition postulate. Okay. And I'm trying to find BX. Now, let's figure out what AX is. Well, AX appears to be a radius of circle A, and we know the radius is half the diameter. So this is actually 5. And AB is the radius of circle B. Well, circle B is 20 centimeters across, so half of that is 10. And I'm just going to do some subtraction here. Subtract 5 from both sides. And I have BX is equal to 5. And again, it's whatever units we have. Then I want to try to find BY. And I notice that BY plus CY is equal to BC. And again, let's look at those relationships that we have. We're looking for BY. We don't know what it is. Now CY is the radius of circle C. And again, the radius is half the diameter, so that's 7. And BC is the radius of circle B, which we already knew that radius was 10. Yeah, because it's half of 20. And again, I'm just going to subtract 7 from both sides, and I get BY is equal to 3. Okay. And that's it. And we're good to go. BY is equal to 3. All right, moving along. Okay, so we worked with our diameters and our radii. Okay, let's do a little bit more work. Okay, so I've got circle W's radius is 4. So this right here is 4, and this WY is equal to 4. The radius of circle Z, that's this circle right here, is 7. So this right here is 7, and then this segment right here is 7 as well. And I'm given that XY is 2 right here. Okay. So the first thing we're asked to find is YZ. Well, let's look at this. Here's Y, here's Z, and here's X. And I know that this is 2, and I know that ZX is a radius of circle Z, so this whole thing is 7. So I have that XY plus YZ is equal to XZ. XY we know is 2, YZ is what we're looking for, and we know that XZ is 7. So we can find that YZ is equal to 5 units, or whatever it is. We want to find IX. Okay, IX goes from here to here. So IX is equal to IW plus WX. Okay. Now, we also know that let's go off to the side here, that, how am I going to put this? I know that this WY is equal to WX plus XY. So from this, I can get the WX is equal to WY minus XY. Okay. Because I know what those are. So let's substitute that in. IX is equal to IW plus this quantity, this quantity right here, plus WY minus XY. So IX is a radius, IX is what we're looking for, IW is a radius, it's 4. WY is a radius, that's 4. And XY we were given, that's 2. So IX is equal to 4 plus 4, which is 8, minus 2 is 6. And last but not least, we're asked to find IC. This is this whole distance across. Well, IC is equal to IW plus WY, so that's this distance plus this distance, plus YZ, this distance here, and then CX, or CZ, sorry, CZ. So IC, well, IW is 4. That was our radius. WY is, oh, did we not find WY? We found WY before. So WY was 4. Okay, sorry, 4. Yes, WY, it's a radius right here. And YZ, we found that before. That was 5. And then CZ is this radius here, which is 7. This is 8 plus 5 is 13. 13 and 7 is 20. 20 units exactly. Okay. So, working with diameters and radii. That's the plural of radius, by the way. Radii. Not radiuses, but radii. Okay. So, let's find the circumference. Remind ourselves that circumference is 2 pi r. That's the distance an ant would walk all the way around. Now, remember that 2r is the diameter. So, we can also write this as pi times d. And that's going to come in handy with this one. So what we've got is we've got this inscribed rectangle. It has a diagonal that goes straight through the center of our circle, which means that this is a diameter. So if we can figure out what that length is, we can figure out the circumference. So this being a right triangle, we know we can apply the Pythagorean theorem. And we know that this diameter here is equal to the square root of 5 squared plus 12 squared. C squared is equal to A squared plus B squared. All I did was take the square root of both sides. So my diameter is equal to the square root of 25 plus 144. Square root of 25 plus 144 is 169. And that is 13. So that's our diameter. So when we're asked to find the exact diameter or circumference, we can say that the circumference is equal to pi times the diameter. So our circumference is equal to 13 pi units, which are centimeters, according to my sketch here. Make sure you're erasing things on your papers whenever possible. Don't turn in something that looks like a fly landed on it and you squashed it. Okay. In this question, we were asked to find the exact diameter rather than the approximate diameter. But again, if we wanted to know what it was, 13 times 3 is 39. So we're expecting something around that. And we get 40.841 centimeters. Okay. Diameter is a distance, and therefore it's just single units. Let's look at this one. We want to find I'm trying to remember. I think we want to find the circumference of this one. So again, circumference is 2 pi r. But in this case, it's probably going to be easier to make it pi times d, because we can probably find the diameter. And I have another right triangle, and you'll find out in 10.4 why we know that this is a right triangle. But once again, my diameter is equal to the square root of 30 squared plus 16 squared. So this is equal to, I think this is 900 plus, 16 squared, 324? 256, sorry, 256. And that is the square root of 1156. So let's start taking numbers out of this. Let's see, is it divisible by 16? Nope. 1156, is it divisible by 64? Nope. 1156, is it divisible by 4? Yes. So this is 4 times 289. Okay, so that's the square root of 4 times the square root of 289. And this one's real fun because this is 2 and this is 17. So diameter is 34. Okay. So our circumference is 34 pi meters. And 34 times 3 is going to be somewhere in the neighborhood of about 102, maybe. So 34 pi, 34 pi equals 106.814. 106.814. I messed up because I was thinking 3.4 rather than 3.14. So there is some more diameter. Okay. So let's work through some of these problems here. We want to find the measure of angle CGB. So CGB. Well, what do we know about this whole angle? Well, it's 180. Minus this at 60. So this is 120 degrees. We want to find the measure of angle BGE. BGE. Well, it's a vertical angle with this one. And we remember that vertical angles are congruent. We want to find the measure of angle AGD. That's AGD. Well, this little symbol helps us out a lot. It means it's 90 degrees. What about the measure of angle DGE? DGE. Well, we know that this is 180 all the way here. This is 90. So this part has to be 90 as well. Well, it's 90 minus this angle right here. So that angle right there we said was 60. So that's 30 degrees. The measure of angle CGD. CGD is this 90 plus this 60. And that's 150 degrees. The last one we're going to try to find here is the measure of angle AGE. AGE. Well, it's whatever this one is plus this one. So this one we knew was 90. And DGE we found earlier was 30. So that's 120 degrees. Let's try to find some more angles. I'm going to pause this. Okay, so I'm actually going to pause this right here and store this as the part 1. And then you're going to have part 2.